Hi everyone, here is one more video. In the last video, we'll recall the types of polynomials according to the number of terms. So what are the polynomials we recall in the previous video? The first one is a monomial, binomial, trinomial, and whatever else, whether it is a 1 or 2 or 3 or 4 or more than 4, whatever else we are calling together as a polynomials. So according to the lower class, only depend upon the number of terms. Here we are going to check the degree of the particular polynomial. According to the degree, we are going to decide the type of a polynomial. So for example, 4x plus 5. When you observe the degree of this particular polynomial, the variable x has a power 1. So if the power is 1, we are calling it as a linear polynomial. So here I have given an example for the linear polynomial 4x plus 5. The general form of the linear polynomial is ax plus b, where a is not equal to 0 is given. Why it's given a is not equal to 0 mean? Suppose a is equal to 0, in the place of ax, in the place of ax plus b, I am going to substitute 0 as a. So 0x plus 7, suppose I am writing. Why they are stressing a is not equal to 0 mean? If a is equal to 0, automatically the whole term is becoming a 0. So only 7 is left out. So for the constant term, there is no degree. Always we have to find the degree by using a variable, the power of the variable. So if a is equal to 0 mean, for the constant term, there is no variable. That's why we are calling as a constant term. The power of the constant term is 0. So totally it is not a linear equation. That's why we are saying always the a is not equal to 0. So according to the degree of the particular polynomial, if the degree is 1, we are calling them as a linear polynomial, and also the value of a is not equal to 0. Here I have given the example x plus 8. The second one is a quadratic polynomial, which is ax square plus bx plus c. So here also again they are saying a is not equal to 0, but they didn't mention whether a b is equal to 0 or not equal to 0, because if it is equal to 0 also it's not a problem. Suppose for example, in the place of a, I substituted 5x square. In the place of b, just for example, I am substituting 0 and then 7. So if the second term is becoming a 0, there is no value for the second term. Even though there is no second term, still the power of the particular equation is 2. The highest power of the particular equation is, the particular polynomial is 2. So they are always saying a is not equal to 0, b may be 0 or may not be a 0, c may be 0 or may not be 0, but a should not be equal to 0. The highest power of the particular polynomial is 2 mean we are calling them as a quadratic polynomial. For that example, 3x square minus 4x plus 3. There is no necessary always the complete 3 terms should be there. Even one term is there, that is also a quadratic polynomial. For example, just 4x square or 7a square, otherwise minus 8y square. So only one term is available. Even though one term is available, the power of the degree of the particular polynomial is 2 mean we can call them as a quadratic polynomial. The number of terms is not at all a matters here, only the degree of the polynomial is important here. Now the next one is a cubic polynomial. Can you say what is the meaning of cubic polynomial? Yes, the degree of the particular polynomial is 3. For example, a x cube plus b x square plus c x plus d. So when you observe this, again same condition, a is not equal to 0. Again same thing, if a is equal to 0, the whole term will become a 0, so we can't consider this as a cubic polynomial. Here I have given the example 2x cube plus 3x square minus 4x plus 6. So the particular polynomial I am taking out and then I am writing. Now when you observe the polynomial, the number of terms we are not bothering, we are checking only the highest power of the degree of the polynomial. Here is a 3. So this particular polynomial 2x cube plus 3x square minus 4x plus 6 is a cubic polynomial. Here also, apart from the highest power, the remaining terms may be there, may not be there. For example, y cube plus 5. Only I have written the y cube plus 5. Even though the number of terms are very less, the highest power, the degree of this particular polynomial is 3. Therefore, we are calling this as a cubic polynomial. So, in this class, we learn according to the degree of this particular polynomial or any polynomial, we are categorizing into 3 types. One is a linear polynomial, the degree is 1. The another one is a quadratic polynomial, the degree is 2. A cubic polynomial, the degree is 3. So let's meet in the next class with the continuation of this polynomial class. Thank you all. Bye-bye.